Okay, hello, welcome to my machine shop here. I have another project here. Somebody gave me a Rockwell saw, a very old one, that they want me to fix for them. What he has is the old blades that have these here L shape. That's how old this saw is. It's all metal saw, Rockwell. And what had happened is, after some time of use of all those years, the clip that holds the blade on broke, and he asked if I could try to replace this for him, build one for him and replace it. And so I'm going to do that. Okay, so this has some different facets on it that need to be machined in. So I'm going to draw this up on my CAD program and get some dimensions and get some measurements made and things. I also noticed on this part right here, in the top part here, that there's a little bit of a break here as well, and this is sticking up a little bit here, and I'm going to assume for right now, until I look into this further, that it's a possibility that the height of this break right here is probably the same height as this part right here, and that probably is used for a little bit of a recess like that, probably to give some sort of spacing for the blade on the machine itself. I'll have to look into that more. But it looks like that there does probably going to come to the same height as that. I'll have to look into that. So that's what I'm seeing on this here so far. Okay, looking at through my magnifying glass here. It's a hardened material. It's a cast material. It's hardened. I can't make any kind of a file groove on it. And it's broken on top here and then split down inside the middle there. Got about 2 threads. I'll have to see what size threads they are, and there's the different facets for it to be machined in. Okay, next we go to the drawing board after we check the thread pitch. Okay, it's a modified screw. Shank is turned down here smooth through a through hole and through here, and then it grips the clip on the other side and clamps the blade. Okay, I'm going to find out what pitch this screw thread is now. Okay, the thread pitch appears to be about 24 threads, maybe a 1024 or maybe a 1224. I'll have to check and see, but it looks like 24 threads per inch. It's standard. Okay, 1 millimeter also fits that. 1 millimeter and a 24 threads. I'll have to put a bolt in there, one metric and one standard, and see which one fits the best in there. Okay, here's a 1024 cap screw, and we'll see how this that seems to be fitting pretty nice. A 1024 cap screw. I think I'll go with 1024 threads for the workpiece. Okay, let's do some temporary gluing here, just so that I can get some measurements. Okay, we'll let that sit for a while until that glue sets. Okay, this here hole is centered on this here part right here. This is even between here and here, and so I would say that would be centered on that. However, in this direction here, it's not centered, so I have to get that measurement there from a baseline. I'll probably start on this side right here, use that as my baseline, and come up and get that hole in line where it needs to be from this side. Okay, since that hole is in the center, I can put a construction line there and then I can come over here, and I got the dimension of the hole itself is about 0.19 for a clearance hole, so I put that on center there, and I got that part. Okay, we'll go to quadrant of that there hole there, and then that will be the hidden lines here for that, and then we can adjust this now to put the hole up here on that side. The top side here has a clearance hole, which is nothing more than just a chamfer on top. That goes about 0.195. But the bottom here has a clearance where there's no threads, and that's about 212 thousandths. And I believe that's so that the screw can fit in there that has no threads on it also. It's to give it the clearance that it needs on the screw. I'll show you. The original screw here has a clearance here where there's no threads, and I believe that's so that can seat into that when it's being tightened onto that clip. So that's what I'm showing here. This is a small hole on the inside where it's going to be threaded, and this is the outside here where it's going to give me that clearance, and then I'll draw that down here to give me the amount of clearance I need on the top and bottom with the chamfer on the bottom. Non-threaded portion here, that's the clearance here. We'll take that measurement down, depth measurement there. Okay, that's an even 100 thou. Okay, so that's from the top here down. We'll offset that 100 thou down to there. And then this will be the clearance right here, and this is the threaded hole down through here. Like that. The 0.147 is a tap drill for 1024. We have a clearance down through here, 100 thousandths of an inch down in depth by that 212 going across for the screw clearance shank. We have one last facet here, that's a 1/4 inch offset to there. That goes this way, and this goes this way, and that finishes out that way. And that's the way that's going to look on top. That's the side view, and I think we have the information we need now drawn up, and now we need to do the dimensions now for it. Okay, it looks like the full width is 415 thou, so if I get a 1/2 inch drill rod, I should be able to do with that. Okay, those two machine surfaces, that will give me the width of the workpiece like that. Now I need to machine for the height of the workpiece. That's a matter of turning this 90 degrees off of 0 here, and that will give me the perpendicular cuts now. on the workpiece. Okay, my workpiece is 500 thou. I need to take it down to 268 thou. That gives me 232 thousandths altogether, which is a depth of cut for one side of 116 thou. Alright, then looks like the next thing will be to work on these here features here now. And that dips down about 35 thousandths. And that's 105 thousandths off of the front. Okay, the next part now would be to cut this here notch out right here now. That's next. Alrighty, got that there notch put in there. And now ready to do the next parts of these. Okay, the next part now will be to machine the bottom side here now. These here facets right here, and that's about 38 thou in depth. It's convenient having this here spin jig like this here. Makes it nice and easy to turn it to get the different facets that need to be machined on it. Okay, so now we're going to work on the bottom side of this here now, putting in those there facets there now. next facet now will be this one right here, and I have to come over to 443 plus the diameter of the bit which I'm using, which is a 1/4 inch diameter bit. Okay, that's pretty much on there. Okay, next up is to do the drilling and the tapping. Now I see why they make ratchet tap drivers when you get in tight spots like this. Alright, that takes care of that part. The next part now will be to make the a little bit of a counter bore for the screw shank to go through. And that's coming up next. This here counter bore here, that goes down 100 thou from the top here. It goes down 100 thou. Okay, set my depth gauge here to 100 thousandths of an inch on top here. I'm using number 3 bit at 212 thou. I need just like 200 and something. Just to it. That's 50 thou. And there is 100 thou. That's it right there. 100 thou. There leaves about 3 threads on the original. Now I'm going to clean up those threads one more time here because that kind of messed up the threads a little bit on the front side here, so we'll just clean those up real quick. Make sure everything's off. Yep. And we'll just clean those up now a little bit once I get the depth gauge off there. There we go. Alright, these threads are cleaned up. Be careful here, we only got a couple threads, about 2 or 3 threads, so I gotta be careful I don't come out too quick. And now we'll try the actual screw that goes with it now. This is a screw right here. You can see the shank right there is non-threaded, and that's to fit inside here, I'm assuming. Okay, that shank goes down the side there pretty good. And then it stops right there. Alright. That's what we want. Okay, when that goes down in, that leaves just a small little gap between the head and the bracket. And that's the same way here with the original too. The screw goes down so far into the original here, and then there again there's that little gap between the head and the bracket. So that's I guess designed that way. And the next thing also is that on this side here, on the other side of the original, there's just a small little chamfer there, little countersink there. So what I'll do is I'll just turn this over 180 degrees and then just take a countersink and just countersink this end here a little bit to clean it up. Alrighty. That looks good. And there we have it. All I gotta do now is cut this off back here and then cut it to final length, and then we'll machine that to final length once I get it cut off, and then that'll be ready to go. Okay, let's go ahead and get this cut off the final length here. Then we'll put it back in the milling machine and cut and machine it down the final length, and we should be ready to go then. Okay, what I need to do now is take it over to my milling machine and machine this to final length now. machine all this on the back side here down to final length, and then we shall have it. And it's be about like that it would be. Alright, good. That going to take off. Okay, here's the finished product. There's the original, and this one we just made. Like I said, this is broken off here on the original, so I put it back on the original, on the new one. Now this right here, I believe this is because these are it's like a cast iron, so this is just a draft here. That's not anything. That's just aesthetic, but that's more like for when they did the casting. I could always chamfer that if I wanted to. There's no need for any kind of chamfer for that like that. Okay, so there's the back side of it, front side of it, and let's go ahead and put it on the saw now and see how it works on the saw. Okay, here's the original piece. I tried to tighten it up and it broke again with the Gorilla Glue, but that's okay because we've got the new one made here now. And I'll show you how this goes on here now. The clip is now on. I put the clip on right here. That's the clip we just made. The blade now hooks on. I never seen these blades before. Hooks on like that. You just tighten it up. And because this is tool steel, this will never break. This broke because this is cast. And there you have it. Every one of these here facets was very much needed. Every one of these here little ledges here and everything, that was needed because that was what holds the blade in position here. So I'm glad that I took the time to take the good measurements and be as precise as I could, because this worked the first time around. Put it in there, nothing bound, nothing got, didn't have to do any kind of reaming or anything. The holes line up perfectly. Everything works really good, and I turned it on, it works good too. Okay, so that was the nice machining project. I really enjoyed doing that, and enjoyed sharing with you guys, and so thanks for watching. Bye.